Okay, so here's an example of static equilibrium using forces and torques that are all balanced to find out some different things about the physics of a bridge. So we have a drawbridge there with a hinge on one side and a cable attached to the other. It has a car in the middle. We have the mass of the car is 900 kilograms. We have the mass of the bridge is 2,500 kilograms, and the center of gravity of the bridge is identified on the drawing as being 1.5 meters away from the hinge. The car is right in the middle of the bridge. And our first question is, what is the tension in the cable? Notice that the cable is at an angle, so we're going to be dealing with some components of forces. We can find the weight of the car and the weight of the bridge just using mass times the acceleration due to gravity. And the next thing we need to remember is that this is balanced, so the net torque is 0. Counterclockwise torques are going to be equal to the clockwise torques. And then we just start putting them in. So we've got the weight of the car and the distance from the car to the pivot point. And next we have the weight of the bridge and the distance of the center of gravity of the bridge to the pivot point. And that's going to be equal to the upward force of the cable and the distance to the pivot point. Plug all those numbers in and you can solve that for a force due to tension. But we don't know what direction that force is yet. We don't know a lot of other things. Well, I guess we do know the direction. It's 40 degrees. It was given to us. We don't have to find that. But what we do have to find next is what force is exerted by the hinge on the bridge. And so we start off with our tension that we found in the first part of this problem and plug it in to get a component in the horizontal or x direction for the tension. And we know that that is going to be the horizontal component that matches the bridge pushing horizontally. We need the bridge pushing vertically, so we're going to take the vertical portion of the tension and subtract off the weight of the car and the weight of the bridge. We end up with our two forces. Use Pythagorean theorem to get the magnitude of the force on the bridge, which is 27,183 newtons, and then we can find the direction because it is a force, it's a vector, it needs a direction. We use the tangent of the angle to find the direction.